Today we're going to do some chemical reactions, and this is the fun part of chemistry where you actually get to see things change their chemical structure. So first of all, just a few terms to be familiar with. The arrow is in the middle, and to the left of the arrow are the reactants. These are the things that you start with, and they're separate to begin with. And then if you have more than one. And then on the right of the arrow are the products, and those are the new substances that have different chemical bonds than the reactants had. When we're writing these reactions, we also have to make sure that we follow the law of conservation of mass, which says that you can't create or destroy things. So if you start with 2 atoms of something, you have to also end with 2 atoms of that something. So that's the reason that we balance these reactions. And we'll talk about balancing in just a few minutes. Be careful if you see something in parentheses after a chemical, it's just telling you the state of matter. So for example, if you saw H2O parentheses L, it means that it's liquid water. Another big one is AQ. If you see parentheses AQ after a substance, it means that it has been dissolved in water. We've talked about in the review unit that we can use those coefficients from the balanced reaction to convert from moles of one thing to moles of another, which is mainly why we use a lot of these reactions. So in AP Chemistry, when you're solving problems, a lot of times you'll have to switch chemicals, and to do that you'll need a balanced reaction, which is why you need to be able to write these. There are several types of chemical reactions that you can look at in the notes. So synthesis is when you put 2 things together. Decomposition is when you break it apart. Single replacement is when you have a couple and a single thing and they switch partners. You get 1 switch. Double replacement is when you get 2 switches, so everything switches partners. And then combustion is usually where you have a hydrocarbon and you mix it with oxygen and get carbon dioxide and water. And these are all in your notes you can look at as well. There's another kind that you did not do in honors chemistry called oxidation reduction, and we'll get to that in another chapter. So first of all, I just want to go over a few tips for balancing. If you're having trouble balancing a reaction, so you should remember this from honors chemistry or from our review unit. If you're having trouble with balancing, let me know and we can go over it in detail. But I'm assuming that most of you kind of remember that you're going back and forth across the arrow to balance the numbers. But if you are having trouble, make sure that you save oxygen for last. It tends to be the troublemaker, so a lot of times you can work everything else out and then oxygen just kind of works itself out. Another trick is to, if you have an odd-even issue, so like you have an odd number on one side and an even number on the other side, you can multiply the odd part by 2. So if you're not sure what to do, multiply the odd number by 2 and then go back and fix everything else except oxygen, and again, a lot of times that'll solve your problem. In the AP Chemistry, some of the balancing gets pretty challenging, so you kind of have to work through your problem solving skills. It's kind of like Sudoku, where you have to solve the number problem to figure out if you can balance the reaction. And then the last thing for today is talking about these predicting the products, especially for single and double replacement. So first of all, let's just review single replacement. This is going to look something like A plus BC yields B plus AC. So you can see that there was 1 switch, the A and the B switched places. A used to be by itself, and then it was in the compound. B used to be in the compound, then it was by itself. So for single replacement, one thing you can do is put charges on everything, put the oxidation numbers that they would become. So the compounds are always plus minus. And then in this case, A happens to be positive. And so if you're trying to figure out what A will switch with, it's only going to switch with the thing that's also the same charge as it. So for example, A can't switch with C because then 2 positives would be together. So you always have to rearrange it so that you get a positive and a negative together. But this reaction doesn't always happen. So what you would have to do is compare the reactivity of A and B in this case and see which one is more reactive. The thing that's more reactive will be in the compound. So in this case, if A is more reactive, then it needs to be in the compound, so this reaction will occur, because notice that over here, it's now in the compound, because it's more reactive than B. But let's just say B was more reactive, then when you look at the reactant side of that reaction, B is already with the compound. So in that case, the reaction would not happen because A is not strong enough to kick out B. And the last type of reaction is double replacement. This is when you have 2 partners and they all switch partners. Be careful when you write your products, and first of all, be careful that you always have a positive first and then a negative. So for this example, it's really easy to write BC on the right instead of CB, because notice on the left, B is on the left, like over here, B is to the left of C, so it's tempting to just go in order, but notice that C is positive, so you always have to put the positive one first. Then what you're trying to figure out for this one is if both of these products are still AQ, because most of the time they're going to start as AQ. So if they end as AQ as well, then nothing has changed, because remember, AQ really just means that you have floating ions. So if we go back to our little solution here, if we had AB aqueous, that just means A positive and B minus floating around. If CD is also AQ, we've got these floating around, so it's just a soup of floating ions. So on the right side of the arrow, if it's still just a soup of floating ions, then nothing has changed. So this is when we say that it's a DNR. So in order for this reaction to occur, one of those products has to be something like a solid, and a solid means that it is insoluble. So when you're using those solubility rules, you want to look up both of the products. You don't really care about the reactants, but you want to look up the products on the solubility rules, see which one is soluble, which one is insoluble, if either of them are. And then the insoluble ones means that it is a solid, and a solid would look different in this beaker. So if for example, whoops, I erased the wrong ones. If CB was a solid, eventually it would sink down here to the bottom and form like a paste down here. And so you see now it looks different. And so that's why we say it does react. Also, anytime you get water as a product, water is considered to be a liquid, and liquid is not the same thing as AQ. So anytime you get water as a product, you can assume that reaction happens, and then it's not going to be a DNR. And that is it for the lesson today. Make sure you practice writing these reactions, balancing them, and as always, check your answer in the back of the book.